this is the what he did yesterday. So might be a little bit different, but I will start with what the Roland did yesterday. So if you save everything at the end of yesterday, you can see this R project file. If you double click it, you can start. Is not saved, so it's an empty space. Then I can start. Don't worry, it's fine. But just start to open the R studio. But please double check you are in the working directory where you worked yesterday. So, okay, just a couple of so as to what you downloaded yesterday, here is the materials, but you can see everything. So today I will start, okay, if you go there, here you can see the list button, and then you can click this. We will work in introductory statistic in R today. So, I will open the R script, new R script. And then, let's start. So before to roll the data set when we practiced it yesterday, I will start with some simple practice. So first, I want to talk about the basic statistic and especially the experiment design part. So experiment design is most important for statisticians. So always people just come to us, okay, here's my data. I want some numbers or especially the p-value or something. And then the first my question is, so could you explain your experiment design? So how is your structure? Like, do you have what kind of the group do you have? Do you have a disease, healthy, and then how many samples you have? And then how you actually doing the experiment? How did you randomize? Did you consider the block design and so on? And most of cases, we very easily can find some issues. So that's why I just want to start to talk about the experiment design. So probably you guys already heard about the randomized block replication. So first one is the randomization. So where you have a, let's say we have a 10 sample, like 5 control and 5 disease one. Always statisticians say don't just run by the order, like healthy, 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 and disease. First step is you need to randomize this order from this way. And then okay, I can do this. I can randomize. I can just take it whatever I can select whatever I want. But if you have a really long list, and then if you have a more complex design, actually you can use the R. And then if you write a script for your experiment design part, and you can repeat it for next time. Also, you can record what you actually did. So that's why I just want to start randomization part. So here, we're going to talk about this chop character yesterday. So this is not about the coding. This is actually make everything is common after the chop. So this is just for recording for what I did. For example, say this is the day 3 for randomization. Just to remind by myself what I did. So shortly yesterday we talked about a function called sample. It's basically the sample. So this is the function. So after you wrote the function name, we always need the certain parentheses, and then we need to put the anything you want. So sample function. Let's say we have a 10 sample, and then we want to select the 3. How to do this? We have a total number. I want to select 3. Okay, so simple. So I run it. Here you can see this time 2, 3, 10 was selected. So you probably have a different numbers, right? If I run again, I have a different numbers. If I run again, I will have a different numbers. So I want to keep what I select. Then how I can do this? Set dot seed and any number you like. I will just put this one and then run the same code, the same sample. Okay? That means I will run these 2 lines together. Here, 3, 4, 7 are selected. And then I rerun this one, and then still I select the same numbers. If I run again, I can still select the same numbers. So it actually gives you some position or something can be referenced, and then after that they can select it, and then you can keep recording what you can select. Yes.
So the seed value itself doesn't matter so much. It just fixes it.
Just fix.
Do the same
Yes,
thing.
just for fixing.
Okay.
So that's good, right? And then, okay, another one. So now I select the 3 out of the 10. But if you want to randomize these 10 numbers, how we can do this is among 10, I will select 10. So if I have a 10 numbers and then if you randomly select 10, actually we decided the order of this. So here, I run this. If I run again, it will different numbers. However, if I set C, any numbers, I run again, this is what I did, and then next time you can also select the same. Okay? So first we practice with the numbers. However, it can be anything. So for example, today is a Friday, so our group member need to clean everywhere, like every room. So among our group member, we want to select the 3 of them to taking care of everything. Then what I can do is, I want to make add our group member's name. For example, me and then team, and then Rojal, and yeah, Oba, and then. So let's say we have a total of 6 people, and then we want to select the 3 members who need to clean everything. So here, now group member is a vector, which includes all 6 members' name. Then what I can do is, I want to sample from group members, how many I want to select, the 3 people. And then now, yes. The land and team and take care of this. So, and you can use anytime. So the first I used these sample things was when I was a grad student. I was TA one of the really big statistics beginning course, and then it turned out the final exam was Saturday 9 a.m. and then we need to decide who's going to proctor. So we use this, like the whole list of the TA, and then we actually use it. We think this is really fair, and we cannot believe anybody else. So we just put the whole list name in this. So yeah, so this is the how to we can randomize it. Then we can move on to the we can move to the block design. So before we go to the block design, let's call our data set what we practiced yesterday. So here our mark. I will load data set. Okay, and then probably just for save. I want to save this file. What was the last one? S05. So I say S05 is basic stat. Okay. Then I will load data we practiced yesterday. So IPRG.RDA files. So here now I can see I wrote my IPRG data. People see this IPRG in the environment, please put the blue or green one. If you have a difficulty wrote this data set, please raise your hand or put the pink one. And then we have a new one here. Okay, so we talk about the randomization, and then we'll talk about the randomized block design. So what is the difference is sometimes we have a really big experiment, like 100 samples, we need to go through the MS1. However, we cannot run everything a day, or sometimes we got the sample January, and then we got the other samples, another batch of the sample July. So complete two different batches, right? Then we want to block means we want to remove, and we don't want to think about this kind of another effect which is we are not interested. Means in the block or any batch, within block or batch, we also want to all the groups we want to compare, and then the other block also we want to include all the groups in another batch. So for that is the block design, and then using our data we can practice it. So first of all, let's get our run information. So I will put ms run, and then want to get unique information of IPRG run. Then, if I check what is the MS run, is here is the 12 raw file names, because we already performed the whole analysis, so now we have a raw file. But you probably have some IDs for your sample, and then they can be the one of the run informations. Then first, just to repeat what we want to do is we just want to complete randomization. Then how we can do it, the sample from MS1 ID, and then we need to give them the number, size of the sampling, and it should be the same number of the run in MS run vector. And how we can get it, this is the length of MS1. So if I said, I just want to check what is the length of MS run. Here we have a 12, we have a total of 12 MS run. And then this is our ID for that. And then if you run this line, it will select the order, randomized order for this MS run. If you repeat again, it will have a different order. If you repeat again, it will give you a different. Then, here is other example for the block design. And this for this, we will use the new package called Psych. So I believe this is based on some psychology study. You know, for psychology study, they really care about the experiment design and then all kind of stuff. And then they already make like all different cases, how we can handle this one. So they actually developed this package, and then we are gonna use this. If you don't have this psych package, go to the pool, go to the install package, and then here you can type the package name you want to download it. Here is a site. If you don't have it, if you have an error message when you run the library site. Okay, so far? Okay. So now we are ready to use the site package. So, for example, let's use this function. But before start to use it, I want to check how I can use this. So always question mark, and then the function name, and then it shows the description here. I also use the R quite a long time and then more often, but new packages coming up, new functions coming up, and then I have no idea. That's why we have this help file. So whenever I start to use the new function, want to look at it, always I'm just searching it, question mark, and then over there. And then here, it shows what they can do, and then what's the function name, and then options. And then here, it shows what is each options means. And then so on. So this is really helpful for me, and then I hope this is also can helpful for you for the futures. And then especially at the bottom, there's examples. You know, this example section is actually required for all the package development, so it should be there. So this is, you can see how I can use this function. So let's try to run what is this means. I will just copy this part and then paste it here. I'm gonna run it. So it shows something, but how I can interpret this. So here, first they assigned n equal 24. It seems like there are 24 samples or something they want to randomize. This is n equal 24, there's total number. And then C and 2 and 3. So it seems we can decide what is the block you have, what kind of the variable you can consider. So I have one variable which have a 2 value, 1 and 2. And then I have another variable value have 1, 2, 3. Then, So we have a 24 and then 2 times 3 and total 6 different combination of the variable available. Then if you assign a total 6 to randomize, and then we can make this 4 different blocks over there. So each block, there are 1, 2, 3, 4 blocks there, and each block, they are randomized these 2 variables. So here, first variable, we can have only 1 and 2, and the second variable, we have a 1, 2, 3, total 6 combination, but they randomly assigned it. If you see the next block, here, we still also have a 1 and 2 value for first variable, and then 3 variable, and then combination. However, their order and their order is different. So for example, let's change the, our terminology. We have a 24 samples. We have 2 groups, healthy group and disease group. For each group, we have a 3 time point. So like 0 at the starting point, and then after 1 month, and then after 2 months, right? So 2, so there are total 6 one we have. And first block, first measurement should be the disease and the first time point, and the second one should be the disease and then first month, and the other one should be healthy and then last time point, and so on. So you can assign this order based on the
Sorry.
yes.
And how, but then the blocks themselves, what do they have for, what meaning do the blocks have?
So for example, if you can only run the 6 run a day, this block should be day. Day 1, you have to run this. Day 2, you have to do this. If you can run 12 runs a day, this 2 can be day 1, the other one should be day 2. But you can follow this order.
Where can you specify in this comment how many blocks you want to have?
So let's just try to something else. So here I can do n equal 24, but I can assign group is C, group equal to duplicate equal 3. And then I will say here so here this function itself, I need to set the number one, or we can assign the rest of these. So for example, here it is the same, right? 24, and then I just change group IDs 2 and 3, but we can desist 2 turns we need it. And then here, I'll run this again. Here, now you can see we have a block 1 and 2, and then within each block, you can see here's the one. Turn is kind of the dummy factor. because we have a 6 combination and total 24, so which means we can actually divide by 4. But I want to make this one is only 2 block, so I just add just another dummy variable to make this one combined. Okay? So this is some practice, but if you don't have a block, if you can run everything a day, here, I will just put the 6 here. Then it shows we have only 1 block, and then you can randomize the 6 combination here. Yes.
So the n number has to be product of your sample possibilities,
Yes.
I guess.
Yes. Okay. Yes.
Could you repeat once the group replicants
So let's, I just want to just naming here, just put it here. So for example, here, if I put the groupies, it just shows the, what column is. So for example, here I can also make the name of the column with the output. So here, and then here I can put the column name for this column, and then it will just make it easy to see it. So it can be different by your experience. Yeah. So if you have, yes.
Can it do that with factors as well, like that is labeled, like for example, male, female, or will not?
Absolutely, yes. So if this is really depending on, so they don't care about the what you have, so you can just, here you can just change, this is the sex, and then this is drop anything if you want. And if you have a TMT experiment or something, one of the factors should be channel, right? So this is just a very simple case, but it can be changed this by your experiment. But I want to introduce this kind of possibility you can use. Okay? Yes. Yeah, we can. Yeah, if you can ask later. Then let's start to do the simple statistic. So our goal for this is we want to subtract one protein what we practiced yesterday, and then calculate the mean, standard deviation, standard error, confidence intervals, and then make a plot. That is goal for this section. Okay? So just try to remind you, this is the very good summary for me also, for when you use the deployer. If you want to select the column, you can use the select function. If you want to make a new column based on your observation, you can use the new. And then if you select the row, you can use the filter. This is most likely what we practiced yesterday. We're gonna use the summarize functions today mainly, but we will combine everything. So, simple statistics. Let's check. First, we need to call tidyverse. What we practiced yesterday. Then, I just want to check. Still, I have an IPRG. So now I believe everyone is familiar with this IPRG. So I hope you also can see these tables. Yes.
Just when we call a library, sometimes we put a single code and what is it with that?
Actually, it doesn't matter.
Can we just
Yeah.
But
When we install the So because when we install the package, in the parentheses, we can put any vector or data name. So if we don't have a quotation mark, which means it can be vector. Okay. But library, we actually manually, individually we need to call it. There's no vector available. So always without the quotation, they recognize this is just package name, not a vector or not data. Okay, so everyone has a IPRG, I believe. Then, first, let's try to get some numbers about the IPRG. Actually, this table shows the how many rows and how many columns and so on. But first, I'm interested in how many proteins this IPRG data. So, what we can do, first, this is just general function. IPRG proteins means what is the unique information of protein column in IPRG data. And then it shows the whole list, all the list, and then it shows up to thousands, and then show them we omit this much entry. So 1,000 plus this one, we have a 3,027 proteins we can guess. However, we can also use the length function. Means what is the length of unique information of protein in IPRG data. So when I run, it will show we have a 3,027 proteins, right? This is just general functions. But we also have this function. This is from the deployer tidyverse package. Here, what is the distinct value of protein in biology, and then what's the number of this? This is the function in the tidyverse, and then it shows the same things. Okay? Same things, right? I will mainly focus on the tidyverse one, which actually has a shorter code line, but I will also try to show the more complicated, like general way we can calculate it. So here is the information, but today I want to work one of the proteins. So I want to get a subtract the whole information for that specific protein, and then protein ID is SP pipe P44015 pipe VAC, it's all capital, 2 and east. I want to extract the row from IPRG data So this means from IPRG data, and then square bracket, and then this is the data. So we need a comma to separate the row and the column. But we want to get all the column, but we want to extract the sum of the row, which contain the protein equal to this. Okay? So I can extract this, but it just show, but I want to save this subtract data some other name, too easy to call it. So here I will call this is just one protein. Okay. Then in my environment, here I have a new data called one protein, which include the 12 rows and then 7 columns. Everyone has a one protein data so far? Good? I will give you the 3 minutes. Could you do the same thing using the dplyr function, pipe function? So I want to call but you need to fill in this one using the pipe function. Use the dplyr of your practice. If you succeed, please put the blue one, like the blue or green one, and then if you have many people succeed, I will go ahead. If you succeed, you should have the same data set in one protein and then one protein dot BCP. So BCP only the backup. So how I can do this? I need to fill in this XXX and XXX. First, we need to start with the IPRG. From IPRG data sent, and then we want to select column and row. Which one? Column or row? Rows. So we have to use filter functions, right? We need to use the filter function. From filter, how we should filter? This is our condition, right? We want to select the rows with the protein ID is this. So I just copy this part and paste it. And then I run it here. Now I can see one protein backup, also 12, the same. Okay? Yes.
Could I also throw out everything which is not?
Yeah. Yeah, actually you can do this. But among the several thousand rows, it's just a 12 and then out of that. So we do it. Then using this one protein, first we are gonna calculate mean. We'll introduce two ways. You can use this aggregate function, just general data format. So here, how I can use it, aggregate and then start a parenthesis. Aggregate. So okay, I want to double check this one protein. So one protein has, I want to check the name of the column. One protein has a protein ID and log 2 intensity and then run. What others not showing is condition bio-replicate, intensity, and technical replicate. So we have to be careful about their capital or lowercase and so on. So I want to aggregate the tilt means by condition. I want to aggregate log by conditions. But where I can find this value? Data, you have to use the data called one protein. So you have to use the data called one protein, and then from one protein, please use condition and then log 2 intensity. But how? And then how aggregate? We need to say this. So how I should aggregate it? Font. It's not font. It's a function. Yeah, and it should be the all capital one. We have to give the function. So what? How I can aggregate? You have to calculate the mean. You have to aggregate by mean for log to intensity by conditions. Okay? So, okay, I run this, and then it show by each condition log to intensity is the mean value of the log intensity. Okay? Otherwise, if based on this function, we can calculate anything by condition. So for example, here instead of mean, I will change SD. SD is also really general function to calculate the standard deviation. So I just change this SD, and then it just calculates SD. Right? And if I just change this one, length means counting how many this value per condition has. Here they can calculate it. Okay. So if you want to calculate, you can aggregate any value by any. So just change as what you want. Then I will change this one is my mean.
Sorry.
Yes.
How does the function actually know that we are working with the data set IPRG?
So we are not working for IPRG. We are working for one protein we already subtract. And here I use the one protein. If you want to do the IPRG, you can just change this as IPRG. But it will be mean for group, mean for condition across all the protein because IPRG have all the. Then I will do the same work with the multiplier functions. So first always multiplier, always start with the data name. So I will start to one protein. Then what we are gonna do? So we want to calculate the mean of log to intensity by condition, right? So first what we have to do is, I want group by conditions. So instead of the aggregate function, we use the group by, so grouping first. Yes, yeah, from one protein, I will gonna grouping this data set first. Then finally, we can use the summarize function. By group, I want to summarize mean of intensity. Okay, so these two lines doing the same job, but I will show you how I can extend this one. So far so good? So good? Yes?
So group by just lumps up whatever conditions are there.
Yes, so the group by, so yes, if you want to group this data by what? Yeah.
So basically, inside one PV there is condition column and there is 9 values. So then we see condition 1, condition 2, like that, and then it is group by condition.
Right. So for me, it's easy to. The group by means I want to separate, digest the data set again. So we already have a subset of like we include only proteins, but I want to digest, separate this data set, and then we're gonna summarize. Then here, if you want to also calculate the standard deviation, I will change this is standard deviation and standard deviation. Okay, I will change this one. Because it doesn't need to be saved. Most likely this is the function, so you cannot change it to summarize it. But this is new column name when you make a new the data set. So you can change this whatever, anything you want to, easy to read it, but this one you have to use the function name. Okay? So if I run this, here it shows the standard deviation, what I calculated by the conditions. Okay? Then, dplyr actually is easy to extend, this summarize. So we use this whole line to calculate the mean and then calculate the standard deviation. Can we calculate all together at once? I don't want to make a really repeat the same code, right? So what I can do is here, as what we did, you can list up in the parentheses of the summarize anything you want. So, which means first, we group by the condition. First calculate the mean, and then next calculate the standard deviation. I run this. Now, yes, they have a one table to calculate whatever you designed it. So if you add more, you can have a more wider the tables. Okay. Then our goal is to calculate the standard errors. So what is the formula for standard error? Is standard error, we can calculate it so unfortunately there is no function for standard error. We have a general function for mean and standard deviation, but we don't have an SE function. So we have to calculate it. So to calculate it, we need the standard deviation and we need the number of the observations. So what we are gonna do, first we are calculate this two, and then manually we are gonna calculate this. So here we already have a mean and standard deviations. I will change this one, that's too easy to do. And what else we need to do is n. We need to calculate the n. How many observations we have. So here, we can, I will call lines, and then we can use n. N functions. So n function is, we already group by conditions, and then they just count it. It doesn't matter of the number of the work intensity. Here I forget to comma. You see here, if you did something wrong, oops, why is not showing? It should show some error. It shows where's the error came from. So here I put them here, and then now. They hide it one more variable, the length. Okay? And then I want to save what I calculated in the new data set. Summary result. Then, if I just check the summary result, this is what we calculated. Okay? Then, okay, so what is the goal? Our goal is to calculate the standard error, and then we have this one, and then we are going to use the dplyr. Yes?
So the length n is calculated. Each group?
Yes, each group, how many measurements we have, how many objects?
You're already inside the group when you're say group 5, and then
Yes, we group by first for each group, like how many observation. So now we have a new table. We made a new table here, and then we want to make a new column. New column include the standard error. Okay. Then if you go back to that the functions ID, so what function we have to use there? Sorry? Mutate. Yes, because we are gonna add one more column in this table. So, summary, we will start with the summary result table. But we're gonna mutate summary result table. How we want to add column name, column called SE, and then here, and then I'm gonna put the formula. So standard E is calculate the first square root. That is a function. We have a function sqrt, calculate the square root, and then parenthesis, and then use the SD column, and then square, and then divide by the length. Yes, I have a typo. It should be, yes, weird, but yeah, this is what I use. Right? Then here, if I run the summary result, there's a length, and then we have a new SE. If you change, if you adjust your RStudio, you can see the full values. Okay. So I will double check. Again, here we have a now mean and standard error and length and standard deviation and standard error. Okay, so we have a summary table. Everything okay so far? Everyone have a summary table? Because for visualizations, we are gonna go to the visualization section, and then we are gonna use the summary result, not IPRG, not one table. We are gonna use this. So everyone should have this too. Okay. Then let's start the visualization. So for visualization, we will use the ggplot2. So I decide to use the ggplot2, and the first action should be we need to call the ggplot2. Right? So library ggplot2, and then it should be like this.
Show the upper code again.
So our goal is I want to show the mean per each condition, and then I want to add the error bar. That is my goal. So let's just start the ggplot. So I start to plot always ggplot 2g, and then I want to use the data summary result, and then I need to say which value I want to put the x, which value I want to put the y. So x is I want to put the condition, and then I want to put the mean value. And to make a nice visualization, I want to color it by condition. And then I will add and add and add more options. So to make it easy, I will say this in the P data. Okay?
Okay, so I will use some.
So ggplot2 again, for me ggplot is kind of what I'm drawing. You know, when you want to draw something, you need the first paper. Or yeah, you can draw somewhere, but I need the paper, right? So always ggplot function for me is bring the paper and then make a square and then just label what is the x and then what is y before I start to drawing whatever inside of this. So make some framework first, okay? So if I just select the P and run, here plot itself not showing anything at all, right? Just make the just frame for what kind of things I want of it. Okay? Then, okay, first what I'm gonna do, I will plot the what is the mean value for each condition. Okay? So from P to P, I want to add point, geom point functions. Then I will check what is the P. So here, it's the same thing, but I plot the P, the mean value on the plot, and then it shows what each column is. It just shows the legend. Is it okay so far? Okay? Okay. You know, for zoom point, and then I just used all the default. However, inside there are so many options. The ggplot2 itself, always I searching what kind of option I can do. So simple one is, I just want to increase the size. Let's say it's a size 5.
So why don't we need to specify
Mean
again?
here?
Is it
Oh,
already specified
because-
as the y value?
no. So here, if you go to the summary widget, okay, I will just show this one. So, oops. Summary value table is that there are many columns which include the numbers, right? So ggplot2 doesn't know. You want to put this column on the y-axis, this column and y-axis, and this column and y-axis. So you have to define that I want to plot this one in my on my file. For example, here you can see here I just put the mean value here, and then you can see the range 21 to 26. But if you change this y value, this SD, and run, and then plot, you can see here's the SD and then calculate it. Yeah, and you can also see that this point is quite bigger. So I will remove this function here, and then I will use mean again. So I just rerun this. Then next, what I will do, P, and then I will add labels. I want to title that mean plus error bar. And I want to change the axis, this condition is okay, but I want to change the y-axis log 2 intensity. Okay, mean of log 2 intensity. Okay, I run this line.
Maybe.
And then draw the P again. Here, now I changed my labels. Here, I changed my label, and then here, I just changed the labels. Next one, I don't like this color of the background. I want the background color to white, and then I want to make a frame. Here, then I can add the theme function actually includes all the options about how you can change the font. So theme by is black and white. Actually, make everything is background is white, and then just use the black line. So I run, and then it shows. Now it's a change it like this. Okay. And then you also can change everything. You don't want this line, you can remove it. You can change the color. You can change the size of this. You can change the color of this. Anything you want to change it, you can find it. So I want to make a little bit nicer plot for publication purpose. So I will use the distinct functions. So first, I want to change the position of this legend. I don't want this legend on the right side. I want to put this legend on the bottom. How I can do this is legend, position, the bottom. Then, yeah, you can see now this legend moved to the bottom one. And if you don't want legend, you can just change none. And then here, now the legend is gone. So this is one of the way. But if you want to change something else, actually you can searching and then find this. So here is the what I want to do. I want to position to bottom. And then I want to change some legend background. The reason why I'm doing, you don't need to type new things. It is already available in the material. But I want to show how flexible this theme function is. So key. So then I run this P. Yeah, something like this. You can change anything you want here. Then, next step is I want to add the error bar. So we plot the mean, but we want to put the error bar there. How I can do this? P, yes?
You move the,
I want to add error bar. We also have a separate function, geo error bar. I want to put the error bar. To put the error bar, we have to assign what is the upper limit and what is the lower limit. You have to give the what is upper and lower, and then they're gonna just draw this line between these two values. So what you have to do is first, y maximum values is SD. Y minimum value is mean minus SD. No, if you have to use SE. 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 And then I select all, run. Yes?
So, these customization features, the of G-Plot itself.
Yes. So if I run here, you can see now we draw the error bar. This is really small, and then this is wide. However, error bar is so wide. I want to adjust this width. So how I can do this is here, I can assign the width is 10% of whatever country what we have. And then run this. Did I do? That's me or something like that. Everyone has this wide width or a small width. You have a wide width? Small one? Wide one? Okay, then I will search Geom error bar. They say what they said. Here. Okay, I will searching this and then I will be back later for this one.
I have a bracket after B minus SC and then red separate things. But then I have a smaller one. I think that was the one, was how you have it.
I had this one before, but I don't know. Is it the same as yours?
No, probably push the window this side, it might look better.
Oh.
The figure might look better if you probably push the window this side.
Anybody who has a narrow one, you have narrow one? How do you get this one? Yeah. Really? Oh, why I still have a wide?
Probably just move the window, move the,
Move size, small?
Did you respect?
I see, I see, I see, I see. Maybe I just run again. So originally I have a wide one and then override the small one, and still the wide one is backside. So let me rerun from here.
Yeah, also did rerun from the very.
Yeah, rerun here. Yes. Yeah. So that's why, yeah. So, yeah.
But
Good.
what was why?
What was the reason? Previously, here, first I draw the P and then override, right? Before I add this one, actually they already have the wide, the error bar, and then after that, I override small error bar, means still the wide error bar is there. So that's why I just start to run at the beginning, which I did not include the option with the wide bar, and then finally it can show the small one.
So you're putting the small on top of the wide one.
Yeah, that was what.
Yes, override it. So I actually not draw with the wide error bar, and then finally it can show what I draw. So this is how I did it, and then, okay, if you want to change the color, okay, maybe we can practice one more overlay one. So, if, this error bar also colored by the group, but if the color is black here, here it show like this. So definitely we can see this. First we dot first, and then overlay the black error bar. So you can see black error bar is across our dot. So if you want to black error bar behind the dot, you have to draw the error bar before you add the point. Okay? Another trick is, currently this is what we have, but we can overlay the dot above here. So just dot, one more, we draw the one more dot, and then here, now you can see the dot with the dot again, overlay the error bar, so you can see the error bar is not across this point. Okay? So, if you want to draw the standard deviation error bar, what you have to do is you can change this standard error to the standard deviation. So instead of the SD, you can change the standard deviation SD. Okay? Yes?
Can I also calculate on the fly in ggplot, or do I have to calculate the numbers before?
Because, do you remember what, summary plot?
Yeah.
This function, we already calculated this.
But if I hadn't,
If you hadn't, you can calculate here, but kind of picky, and then high chance to have some error. Then next, I just want to just a little bit more, so we can calculate the error bar for standard deviation and standard error. I want to calculate the confidence interval, 95% confidence interval, and then want to draw it. Okay. Then, if you go to this one, there's a formula. confidence interval. Here, we will use this formula, and we are going to calculate the confidence interval, and then we will make a same plot. Okay? This is kind of the commonly what you have to use it for plot, bar plot, or point plot, and then you need to make a error bar over there. So how we can calculate it? So if you go back to our summary result plot, a summary result table. Here we have a mean and standard deviation and length, and then standard error. How we can calculate the confidence intervals is, and I want to add my confidence interval here in the same tables. So which means I have to use mutate functions. Yes. So summary result, summary, the mutate, I want to calculate the lower limit for confidence interval. How I calculate it is mean minus this, and then upper bound is exactly same instead of minus, we have to change the plus. So we have a 95 percentile percent, and then this is the two sides. It should be 22.5 and 2.5. So we used 97.5% quantile with the degree of freedom should be length -1. So we can calculate this value, and then we have to multiply by standard error. And then this is lower bound, which means we have to minus from the mean. But upper bound, exactly same, but it should be plus from the mean. Okay? So I run this error. Why we have an error? Oh, yeah, I have a typo for length. I have some different name.
I think just for
You had
which
X.
summary reserved as
GGT.
data.
Yeah, sure. So yes, I have a really weird name. Yeah, sorry. So it's not found. Oh, data. I have to put the data. I have to put the summary result and this. Here. Now we have a more values, and then it's a hidden, but we have an upper value. Okay, here. Then I don't want to type everything again, so I will back to our previous script, and then I will start to rerun again. Because now somewhere result we have more columns. So I will start from this again. So here I will make a frame, and then I add the point, and then I add the title. I change the background. I also change the theme. And here, only things I want to change is the error bar. So at this stage, instead of here, I will say this is maximum, this should be upper. So it should be lower. So previously, standard error and standard deviation, we only calculate this distance, but the lower and upper for confidence interval, we already add the mean value and also minus value. So we just can use this upper bound one. Then I will remove this color black. And now you can see this plot. The same things, but I only changed the error bar values. So now you can see previously we have a very narrow error bar with the standard error. Now you can see with the confidence interval, you can see very wide error bar. You can see this. Okay? Okay, so we have a couple of minutes left. But, okay, then I want to save this widget because maybe I can come back. So how I can save these files, summary widget, which what we calculate so far. File, it should be under data, and then summary. Electrical summary, because it seems there are several other files for backup with a very similar name. So here, save. Then you can just call this summary table later, whenever you want. Okay? So call in a ggplot2. I just want to show some really how you can extend this ggplot2. It's .org. Do you have a same plot? Same. Yeah, here we go. This is the website to display all extensions from the ggplot2. So from the ggplot2, they make quite a lot of the package for visualization. So, for example, they use the same frame as the ggplot, but they made a new plot, gg animate, and then you can see actually you can animate those. And then, like all the graphs and themes, and so on. Here, you can see there are so many tools start from the ggplot, like this. So if any other package or any other visualization you're interested in, you can download the package, but you can use the same syntax as a ggplot. So very similar, flame and overlay and overlay and overlay, and there are many options are there. And if you want to look at the more ggplot2 ggplot2, Basic. Here, this is for ggplot2. This is the web page, and you can see all the options in the ggplot. Here, for example, here, contents, weighting, layer, stat. They also support a very simple stat. And then here, if you look at here, there are also so many sub-functions within that, and then you can use any of this for your purpose. And then you can also find all the reference. Okay? So if you are taking the visualization course, probably you can make a more nice and then for high dimensional data set. If you're taking for stat MS, we are not much focused on using the new function. We are going to mainly focus on statistic, and then it will provide a basic visualization. However, you can also naturally use any other ggplot or any other extension package for this. If you are not taking most of this, use anything, and then there are many sources over there, so you can search in this. But my goal is want to deliver what is the basic themes and basic entities that you can use. So I think we're okay. We are done, and then we will stop the morning break, and then I will be back the last section, which will be really exhaustive time. But yeah, let's take a break, and then I will be back.